Okay, in this lecture, Fractions Lecture 6, we shall be dealing with the concept of addition and subtraction of fractions. Okay, let's get into the lecture. Two fractions can be added or subtracted if both have the same denominator. Take note of this. Two fractions can be added or subtracted if both of them have the same denominator. But if the denominators are not the same, what we do is to simply convert the fractions to their equivalent form, ensuring that they have the same denominator. If the fractions are not the same, take note, we simply convert the fractions to their respective equivalents with the same denominator. Okay, we are going to explain that to you even as we progress in the lecture. Now let's look at case 1. If they have the same denominator. So in this case 1, if the fractions have the same denominator, what we are going to do is to simply add or subtract the numerators and then divide the result by the common denominator. See what we are trying to explain here. For example, example 1, we have 1/7 plus 5/7. You can see that these two fractions have the same denominator, which is 7, right? Okay, so the rule here says if they have the same denominator, what we are going to simply do is to add or subtract the numerators. But in this case here, it was 1/7 plus 5/7. So what we are going to do is to add the numerators. So this is what we are going to have. 1/7 plus 5/7 is equals to 1 plus 5/7. We simply added the numerators and divided it by what? The common denominator, which is 7. So 1 plus 5 equals to what? 6. And then all over 7. So that's the answer. 1/7 plus 5/7 is equals to what? 6/7. I hope you understand this. It's as simple as this. Okay, let's look at example 2. Example 2 says 5/11 plus 3/11 minus 2/11. Of course, you can see that all these fractions have the same denominator, which is 11. So we are going to simply operate on the numerators. So this is equals to 5 plus 3 minus 2 all over the common denominator, which is what? 11. So 5 plus 3 is 8, then 8 minus 2 is what? 6 all over what? 11, the common denominator. So that is the answer. It's as simple as that. Okay. Example 3 says 8/17 minus 9/17 minus 5/17. Of course, you can see that all these fractions have the same denominator, right? So this will be equals to 8 minus 9 minus 5 all over 17, the common denominator. So 8 minus 9 gives us minus 1. Then we now have minus 1 minus 5 all over 17. So minus 1 minus 5 gives us minus 6 all over 17. And that is the answer. I hope you understand what we just explained. Okay, example 4 says 2 whole number 1/5 minus 1 whole number 3/5 plus 4/5. The first thing we are going to do here is to convert the mixed fractions to improper fractions. So converting the mixed fractions to improper fraction, remember, we are going to simply say for the first one we have 5 times 2, which is 10, plus 1, 11. So we are going to have 11/5. Then the second one is which is 1 whole number 3/5. We're going to have 5 times 1, which is 5, then plus 3, and that gives us what? 8/5. I don't expect you to have any challenge in this conversion process, because in one of our lectures we were able to teach you how to convert from mixed fractions to improper fractions. Okay, so converting this, we had 11/5 minus 8/5 plus 4/5. You can see that all of these fractions have the same denominator. So what we are going to simply do here is to operate on the numerator, and this is equals to 11 minus 8 plus 4 all over 5. 11 minus 8 gives us 3, then plus 4 over 5. Then we now have 3 plus 4 gives us what? 7 over 5. That's the answer. But if you want to convert it back to improper fraction, we are going to simply say 7 divided by 5. That is one whole number with a remainder 2. Then all over the original 5. I hope you understand what we just explained. Okay, let's solve one more example here. Now, the question says 3 whole number 7 over 8 plus 5 over 8 minus 2 whole number 7 over 8. So we are going to first convert the mixed fractions to improper fractions, right? So converting that, of course, for the first one, we are going to say 8 times 3, that's 24. Then 24 plus 7, that gives us what? 24 plus 7 gives us 31. Then for the last mixed fraction, we are going to say 8 times 2, that's 16. Then 16 plus 7, that gives us what? 23. So converting this, we had 31 over 8 plus 5 over 8, then minus 23 all over 8. I hope you understand what we just explained there. Okay, so now you can see that the denominators are the same. So we are going to now operate on the numerator. So we are going to have 31 plus 5 minus 23 all over 8. So 31 plus 5 gives us 36, then minus 23 over 8. So we now say that, you now say 36 minus 23, that gives us 13 over 8. And that is the answer. Of course, if you want to convert it to mixed fraction, you are going to simply say 13 divided by 8. That is one whole number with a remainder 5 all over the original 8. I hope you understand this explanation. Okay, let us advance into case 2. Now, case 2 says, if the fractions have different denominators, what we are going to simply do is to look for the lowest common multiple, the LCM of the denominators, and then use it to get the equivalent of the respective fractions having the same denominator. In one of our lectures, we taught you how to find the LCM. So we are going to apply the knowledge of the LCM here in converting a fraction to an equivalent fraction. So whenever a fraction has different denominators, do not panic. The first thing you have to do is to look out for the LCM of the denominators. Then use the LCM to obtain the equivalent of the fractions having the same denominator. Okay, in our examples here, we are going to explain that to you. Let's solve some examples to help you understand what we just explained. Now, we have 2 over 5 plus 7 over 9. If you look at it carefully, you can see that they have different denominators, right? 5 and 9, they are different. So what we are going to first and foremost do is to look out for the LCM of 5 and 9. So the LCM of 5 and 9 is 45. We hope and we expect that you know how we got 45. But if you have any challenge in finding the LCM, please, we will advise you to go back to our lectures on LCM. Then you can now come back to this particular lecture. So, but if you understand how to obtain the LCM, let's advance. So the LCM of 5 and 9 is 45. So what we are going to now say is this. Please look up and pay keen attention. First thing we are going to do is to convert these fractions to their equivalent form, ensuring that they have the common denominator, which is 45. So now let's begin with this 2 over 5. So 2 over 5, beginning with it, we are going to have, now see what we did here. We now carry the LCM 45. We now said 45 divided by the denominator, which is 5, then times 2. Take note. We said 45 divided by the denominator 5, right? Then times the numerator 2, all over 45. Then for the second one, we also said this 7 over 9 is now equals to, we are going to say 45, this LCM, divided by the denominator 9, then times 7. Take note of what we did here. Please pay keen attention. Here we said 45 divided by 5, then times 2 to get this, all over the original 45. Then here we said 45 divided by 9, the denominator, then times 7 to get this, all over the 45. I hope you understand what we did there. Okay, coming back to here, 45 divided by 5, that will give us 9, then times 2, all over 45. Then of course, you know 9 times 2 gives us 18 over 45, right? Then coming here, we have this 7 over 9 gives us 45 divided by 9, that gives us what? 5. Then times this 7, we had this, all over the original 45. Of course, 5 times 7 is 35 over 45. So you can see that we have been able to convert 2 over 5 to have 18 over 45. And we have been able to convert 7 over 9 to have what? 35 over 45. I hope you understand this. Okay, from here, we can now say that it means that 2 over 5 plus 7 over 9 is equals to 18 over 45 plus 35 over 45. You can see that these two fractions are now having the same denominator. Of course, this is the equivalent form. So from here we can advance. We can now add them together. That's 18 plus 35 all over 45. 18 plus 35 gives us what? 53. Then over 45. And of course, if you convert that to a mixed fraction, we say 53 divided by 45. That gives us one whole number, remainder 8 over 45. I hope you understand what we just explained. Please, if you have any difficulty, we will encourage you to look through the lectures again. Okay, let's solve example 2. Example 2 says 11 over 15 minus 2 over 3. You can see that the denominators are different, right? So what we are going to do here is to simply find the LCM of the denominators, which is 15 and 3. So the LCM of 15 and 3 is what? 15. You can confirm that. Now, we have to convert the first one, 11 over 15, to an equivalent form with the same denominator of 15. Of course, we are going to say 15 divided by 15. See what we did here? The LCM 15 divided by this 15, right? Then times 11. So we got this. And this 2 over 3 is equals to, we said this LCM 15 divided by 3, the denominator, then times 2 to get this. All over 15. Now, of course, 15 divided by 15 is 1. Then times 11. We got this over 15, and that gives us 1 times 11, which is 11 over 15. And 2 over 3, when solving this, we said 15 divided by 3. That gives us 5. Then 5 times 2 over 15. So 5 times 2 gives us what? 10. All over 15. I hope you understand what we just explained. So we can conclude that it means that 11 over 15 minus 2 over 3 is equals to 11 over 15. Of course, because 11 over 15 still gave us 11 over 15, right? Then minus 2 over 3 gave us 10 over 15. So we now have minus 10 over 15. You can see that these are what? Equivalent fractions. So what we are going to simply do is that since they have the same denominator, we are going to say this is equals to 11 minus 10 all over 15. 11 minus 10, that gives us what? 1 over 15. And that is the answer. I hope you understand what we just explained. Okay, let's look at some further examples. Now, the first one says 6 whole number 1 over 5 minus 2 whole number 3 over 4 plus 1 whole number 1 over 6. Now, they are mixed fractions. So the first thing we are going to do is to convert the mixed fractions to improper fractions. On converting that, we have, of course, this is 5 times 6. Look at it. 5 times 6, 30 plus 1, 31 over 5, right? Then this one gives us 4 times 2, 8. 8 plus 3, that's 11 over 4, right? This will give us 6 times 1, 6 plus 1, 7 over 6, right? Okay, so that's what we got. 31 over 5 minus 11 over 4 plus 7 over 6. You can see that the denominators are different. So what we are going to first and foremost do here is to find the LCM of the denominator, which is 5, 4, and 6. So the LCM of 5, 4, and 6 is what? 60. Please, you can confirm that. Now, we can now say that this, of course, 31 over 5 minus 11 over 4 plus 7 over 6 will now give us, now, for this first one, for this first fraction, we said 60 divided by 5 times 31, and we got this. For the second one, we did what? We said the same 60, which is the LCM, divided by 4, then times 11, then we got this, right? Then for the next one, we said the same 60 divided by 6 times 7, then we got this. So when we simplify this, we're going to have 60 divided by 5 is 12 times 31 over 60. Then 60 divided by 4 is 15 times 11 over 60. And 60 divided by 6 is 10 times 7 over what? 60. Then when we solve this, 12 times 31 gives us 372 over 60. And 15 times 11 gives us what? 165 over what? 60. Then 10 times 7 gives us what? 70 all over what? 60. I hope you understand this. So you can see clearly that these are the equivalent form of these fractions and they have the same denominators. So what we're going to now do is that we're going to operate on the numerators because these are equivalent fractions. So it means that this will now be equals to 372 minus 165 plus 70 all over 60. And that gives us 277 over 60. Then that's the answer. But if you want to convert it to mixed fraction, we're going to simply say 277 divided by 60. That gives us what? 4 whole number, remainder 37 over what? 60. I hope you understand what we just explained. Okay, let's look at this other example again. The example says 9 whole number, that's simplified 9 whole number, 1 over 3 plus 5 whole number, 3 over 4 minus 6 whole number, 1 over 2. Of course, they are all mixed fractions. So the first thing we are going to do is to convert the mixed fractions to improper fraction. On converting that, we simply say 3 times 9, that's 27 plus 1, 28 over 3, right? We now say 4 times 5, that's 20 plus 3, that's 23 over 4, right? We now say here 2 times 6, 12 plus 1, 13 over 2. So this is what we got. I hope you understand that. Okay, now you can see clearly that the denominators are different. So because they are different, we are going to find the LCM. The LCM of 3, 4, and 2 is 12. You can confirm that. Okay, now we can now say this, of course, that 28 over 3 plus 23 over 4 minus 13 over 2 is equals to, we now use the LCM, we now say 12 divided by 3 times 28 to get this, right? For the second one, we say the 12 divided by 4, this 12 here, divided by 4 times 23, we got this, right? Then this other one, we say 12 divided by 2 times 13, so we got this. I hope you understand this. Okay, so now on simplifying that, we have 12 divided by 3 is 4, then times 28 over 12. For the second one, we had 12 divided by 4, which is 3, right? Times 23 over the 12. For the third one, we have 12 divided by 2, that gives us what? 6. Then times 13 over the 12. Now simplifying this, 4 times 28 gives us 112 over the 12. Then 3 times 23 gives us what? 69. Of course, over the still 12. And we now have 6 times 13, that gives us what? 78 over 12. You can see that these are equivalent fractions because they have the same word, Now, these are equivalent fractions with the same denominator. So, we can now say, since these fractions have the same denominator, we can now operate on the numerators. So, what we are going to have is 112 plus 69 minus 78 over 12. Of course, that gives us 103 all over 12. That's the answer. So, but if you want to convert it back to mixed fraction, we're going to say 103 divided by 12, and that will give us 8 whole number, remainder 7 over the original 12. I hope you understand what we just explained. Okay, let's give you something to play with. Now, take down this question. Simplify the following. A, 4 whole number 3 over 4 minus 1 whole number 5 over 8. B, 2 whole number 3 over 4 plus 3 whole number 2 over 5 minus 1 whole number 2 over 3. See you in our next lectures, because we've come to the end of this particular lecture. In our next lecture, we shall be looking at mixed operations involving fractions. Thank you for your attention.